Okay, good afternoon, class. Right. Okay, so today actually I just want to discuss for the exercise that we still didn't finish discuss, right? This one and also the exercise I give you in the GC, okay, exercise 1 and also exercise 4.1. Okay, and I think I already assigned for you homework 4.2, right? Specific heat capacity and also exercise on paper 3. So I hope you can submit, right? And turn in to me so I can check, right? And then we can discuss on next Saturday, okay? And also, I just want to tell that actually I already done for paper 1, okay? Form 4 physics for every chapter. So it's about like 262 pages, okay, for paper 1 only. Okay, and now I'm doing paper 2. So this one I will photocopy for each of you. For this one you don't need to pay, okay. I will use the school money to pay, and I will put in the canteen, okay. Same like you take the module, so you can just go and take there, okay, when the MCU is over lah. Right, or maybe we on a phase 2 because now everyone cannot go out, right? Okay, except for if you are working. So this one, and then after that, we only use this one to do the exercise. So I don't need to give another worksheet, okay? All right, so we go for this one first, right? So here it said diagram 11.1, okay? Shows the national speed limit and load limit for federal roads in Malaysia, right? So the first question asks you what is the meaning by speed, okay? So speed and velocity, the difference is speed is a scalar, right? And the velocity is the vector, okay? For the scalar, they only have the magnitude, while the velocity, they have a magnitude and also the direction. Okay, so for speed, what does it mean by speed? It's a rate of change of distance. Okay, rate of change of distance. Right, so you can write here rate of change of distance. Okay, rate of change of distance. Okay, so that one is for 11A. Right, for the next question, for B, using the concept of momentum and inertia, explain why the speed and the load limit must be imposed on heavy vehicle as depicted as in diagram 11.2. Okay, so why must we have a speed and the load limit? So any idea why we should have a speed and load limit? So this one you have to use the concept of momentum and also inertia. So what is the formula for momentum? What is the formula for momentum? Anyone? What is the formula for momentum? mv, right? So mass multiplied by velocity. All right, very good. Okay, so from that we already know, right? So if you increase the speed, okay, if you don't have a limit for speed, okay, so the momentum will be increased, right? So if the speed increase, the momentum will also be increased. And you already know the impulsive force, right? The impulsive force, that is, they use the momentum, right? So this also will increase the impulsive force, right? And then for the inertia, what you can use the concept of inertia here. So inertia is actually, it depend on mass, right? So it depend on mass. So the higher the mass, the higher the inertia. So mean it will take more time, right, to stop. Okay, so that's why we should have the speed and also the load limit. Okay, so how you want to explain this one? So the first mark, okay, because this one is 4 marks, so 4 point. So the velocity, okay, wait for a moment. Okay. You give the formula of the momentum. Okay, so momentum is mass multiplied by velocity. Okay, so the higher the mass, Okay, the higher the mass, the higher the momentum. The higher the momentum. Okay, so for this one, you already got 1 mark. Okay, here from the momentum mass multiplied by velocity. Okay, the second mark is the relationship between the mass and also the momentum. Okay, so the higher the mass, the higher the momentum. Okay, and then the second one is about the inertia, right? So the inertia is depend on mass. Okay, so the higher the mass, the higher the inertia. Okay, and it will take, okay, longer time for vehicle to stop. Okay, so that's the explanation. Okay, so the momentum is the mass multiplied by velocity. So the higher the mass, the higher the momentum. Okay, and you already know the momentum is actually, we use also momentum to calculate the impulsive force. Okay, and then the second one, if you want to connect the inertia with the mass, alright? So inertia is depend on mass. Okay, remember, not mass, not weight, right? So the higher the mass, the higher the inertia, and it will take a longer time for vehicle to stop. So let's say if the driver want to if the driver want to stop, okay, want to stop the vehicle, it will take some time. Okay, so that is the question number B. Okay, answer number B. Okay, and then for C. Okay, for C, this one you have to make a table. So I noticed some of you, they answered the question for this one, they didn't answer in table. Okay, I think I give 4M, right? The exercise during the holiday. And I think like 2 or 3 of you didn't answer using the table. So please, okay, if you don't answer using a table, I will not mark your exercise. Okay, so do in table. Okay, so how you want to do table? So there are 2 columns there. Okay, 2 columns there. The first one is the characteristic and explanation. Okay, or modification and explanation. Okay, but for this one, we didn't modify. That one is the question number 9. Okay, so the characteristic and explanation. Okay, for the first, they said here, the table 11.3 shows 4 tankers, right? K, L, M, and N with different specification. So you are required to determine the most suitable tanker to deliver high flammable fuel safely. Okay. So for the tanker, so of course you need to have the 5 small tanks. Okay. This is actually to reduce the effect of inertia. Okay, to reduce the mass. So when the mass is reduced, okay, the effect of inertia also will be reduced. Okay, so for this one, you have to choose 5 small tanks. Okay, so why? Okay, because it can reduce the effect of inertia. Of inertia. Okay, so that is for number 1. Okay, for this one, the number of tires. So what it should be, 4 or 8? 4 or 8? 8. Why? Why you should have 8 tires? Why you should have 8 tires? Why you should have 8 tires? What happened if the heavy vehicle only got 4 tires? What happened to the pressure? High. Yes, so this one is also to reduce the pressure, and also you can say to make it more stable. Okay, so 8 tires. Okay, to reduce the pressure. Okay, to reduce the pressure. So that's why you need to have 8 tires. Okay. For brake system, so which is the most suitable for the brake system? ABS. Okay. So why you need to have the ABS brake? Why do you need to have the ABS brake? To avoid from skidding. Yes, correct. Okay. To avoid from skidding. Okay, and then the last one. Okay, the distance between the tank and also the tanker head and also the tank. So you need to have a distance. All right. So whenever let's say it crash, okay, so you will not hit the tank there. Okay, so it will not be explosion. Okay, there will be no explosion. Okay, so for this one, it say it needs to the distance need to have a long distance. Okay, long distance of tanker head. Okay, so make sure you answer it fully. Okay, full sentence. Okay, and time. Okay, so this one is to avoid impact. Okay, during collision. Okay, to avoid impact during collision. So from this one, which one we should choose? K, L, M, or N? M, right? M. Okay, so how you want to answer this one? So I choose M, okay, because, okay, you copy back all the characteristic there, right? Because 5 small tanks, okay, and has 8 tires, okay, and has ABS brake and long distance, okay, of tanker head and tank. Okay, so you got 1, 2, 3, 4, 5, 6, 7, 8. You choose correct, got 9 marks, and also you copy back all the characteristic, you got 10 marks. Okay, so this is how you want to answer. Okay, this one is actually before in KBSM. This one should be question number 11 and 12. Okay, section C. But now they change it to section B. So now this will be question number 9 and also number 10. Okay, number 11 is the one that you're doing right now. Remember to cool, to make it cool faster, right? The ice, the one that I give the exercise for exercise 4.2, right? So that one will be question number 12. Okay, sorry, number 11, because you only got one question for section C. You cannot choose. Okay, so only one question, number 11. Okay, so this is how you answer for question number 9 or number 10. Okay, so this is actually the old format. Okay, now let's see for number 6. Okay, so diagram 6.1 shows two cyclists cycling the bicycle and reach the distance shows in 3 seconds. So for 6.1, it only takes 3 seconds to reach the distance of 30 meter. Okay, for diagram 6.2 shows only one of the cyclists cycling the bicycle and reach the same distance in 7 seconds. Okay, so 6.2 is reached in 7 seconds. Okay, but the distance is same, 30 meter. Okay, so name the force which acted between the bicycle tire and the road. So this one, anyone can answer? For A, what is the force that acting between the bicycle tire and the road? Frictional force. Okay, very good. Frictional force. Okay, for B, based on diagram 6.1 and 6.2, compare the force applied by the cyclist that caused the bicycle to move forward. So remember this one, they take 3 seconds. This one takes 7 seconds. So which one has the higher force, 6.1 or 6.2? 6.1. So how you want to answer here? So the force applied by the cyclist for 6.1 is higher. Okay, and you have to compare the time. Okay, the second question asks you to compare the time taken to travel the same distance. So here they already tell you this one, the 6.1 is 3 seconds, 6.2 is 7 seconds. So you know, you can say 6.1 take a shorter time, or you can say 6.2 take a longer time. Okay, both also can be accepted. So this one I will say 6.2. Okay, diagram 6.2. Okay, take longer time to travel in same distance. Okay, so for the comparison, I notice some of you when they compare, right, they use big, okay, big, bigger, okay. But remember, for big and bigger, usually we compare it if size. Okay, they say size of balloon. For size of balloon, you can say bigger. Okay, but let's say it compare a force. Okay, so don't say that the bigger the force in diagram 6.1 is bigger. Right, bigger is actually for the size. So we make sure you use like higher or lower. Okay, that one is better. Okay, so use the comparison words correctly. Okay, so bigger, if bigger, I will not accept. Okay, so bigger is only for the size or volume or easily size. Volume also cannot. Okay. Alright, for number 3, based on the answer in 6B2, compare the acceleration. So of course the acceleration for 6.1 is higher. So the acceleration for 6.1, okay, the acceleration for 6.1 is higher. Alright, relate the force applied by the cyclist to the acceleration of the bicycle. So this one, the higher the force, the higher the acceleration of the bicycle. So the higher the forces applied, okay, by the cyclist to is the higher the acceleration of the bicycle. Okay, for C, what is the physics law that involved in this one? So they have a force, they have the acceleration. So what is the physics law involved here? What is the physics law involved here? Any idea? F and A. We already learned in chapter 2. Newton's second law. Yes, correct. Newton's first law is the inertia, right? The tendency of an object, right? To avoid any other force that change the motion, okay, that make it change in motion. Okay, so that one is the inertia. Okay, for the Newton's second law, that is F is equals to ma. Okay, so the higher the force, this one is not the rate of change of momentum, okay, is directly proportional to the force. So that one is the Newton's second law. Okay, very good, Kai. Okay, so this one is Newton's second law. Okay, what happened to the acceleration of bicycle in diagram 6.1 when both cyclists bend the bodies forward? So any idea what will happen to the acceleration? Is it will increase or decrease, or it will not change? Right? So if they ask you what happened, okay, to the acceleration or what happened to any other physical quantity, so the answer only 3: increase, decrease, no change. Okay, so for this one, when the bodies bend forward, Okay, it's bent. So mean it will decrease the frictional force, right? So the frictional force will be decreased. So when the frictional force decrease, okay, so this one will increase. The acceleration will increase. Okay, it will reduce the air friction. Okay, it will reduce the air friction. Okay, for number 3, the resultant force of what when the effect of air resistance of what? So what happened to the resultant force when the air resistance of what? Any idea? The resultant force will what? So they say the increase, decrease. Yes. The resultant force will increase, okay, when the effect of air resistance decrease. Okay. Right, very good. Okay, now let's move on to the last question, I think. Yeah. Okay, number 12. Okay, so diagram 6.1 shows an athlete is conducting a high jump. So diagram 6.2 shows the same athlete jumps at higher height, right? So what does it mean by impulse? Okay, so impulse, impulsive force. Okay, so what does it mean by impulse here? Impulse, impulsive force. Impulse is the change of momentum. Okay, very good. Change of momentum, while the impulsive force, rate of change of momentum. Okay, and how about the formula for impulse? So impulse, they have a formula. Ft is equals to mv minus m1. So you only can use one of this formula, whether ft or mv minus mu. Okay, so that's the meaning of impulse. Okay, for impulsive force, right, what is the formula for impulsive force? M is equals to mv minus mu divided by t. Okay, so for this one, if you want to decrease the impulsive force, you have to increase the impact of time. Okay, so let's say for the car, they have the crumple zone, okay, in front of the car. So that's one is actually to increase the impact time, and so the impulsive force will decrease. Okay. All right. So what does it mean by impulse here? Change of momentum. Change of momentum. Okay, we move on to the next one. Explain how the mattress prevent the athlete from severe injuries. So how does the mattress can prevent the athlete from getting injured? This one must have it connected with the impulsive force. Yes, increase time impact one mark, and also decrease impulsive force second mark. Okay, so this one increase impact time. Okay, and decrease impulsive force. Okay, so 2 marks. Okay, for C, okay, they ask you to compare the mass of the athlete. So the mass of the athlete is same because it said here the same athlete. So if the same athlete means the mass is same. So here mass is same. Okay, and then the height of the high jump bar. So the height for the diagram 6.2 is higher. Okay, you can answer like this also. 6.2 is higher than 6.1. Okay. How about the final velocity of the athlete before landing on the mattress? Okay, so for this one, which one should be higher? The 6.2 or 6.1? 6.2. Okay, because you know velocity is displacement against time, right? So here, if the height is higher, means the displacement is higher compared than 6.1 here. So when the s is higher, okay, the velocity is also higher. So 6.2 is higher than 6.1. Okay, very good. Okay, based on your answer in 6C, state the relationship between the height of the high jump and also the final velocity. So this one I just give you the answer. Okay, the higher the height of the high jump bar, the higher the final velocity. Or you can use directly proportional. Also can. Okay, you can say the the height of the high jump bar is directly proportional to the final velocity. Okay, and for E, okay, based on your answer in 6C, state the relationship between final velocity and impulse. So this one also is actually directly proportional. So the higher the final velocity, the higher the impulse. Okay, so you can put the graph relationship also in the comparison, okay, in the relationship for paper 2. But for the paper 2, in the relationship in the paper 3, when they ask you the relationship of the graph, you cannot put the higher the lower. You have to put directly proportional or increasing linearly. Okay, so I will see how you answer in paper 3 later. Okay. Alright, so we move on to the next chapter. So the next question. So this one is what does it mean by velocity? Okay, I just give answer because I know that some a certain question that I need to discuss. But for this one, most of you got it correct. Okay, rate of change of displacement. Okay, rate of change of displacement. Okay, when you give answer, make sure you give only one answer. Don't give like rate of change or displacement or, okay, give only one answer. If you give me two answer, it's mean like you ask me to choose. Okay, so give me one answer only. So rate of change of displacement. So what is the total displacement from P to S? So for this one, okay, so this is the direction of the boat. Okay, so some of you confused, right? They thought that this is like a ticker tape. Okay, so for ticker tape, I know the direction of motion to the right, right? So this one come out first, right? But for this one, this is not a ticker tape. This is a direction of the motion boat. So if we just follow the direction, it start from here to, from P to U. If ticker tape, yes, from U to P. Okay, so later when the school open, we can do the experiment about the ticker tape. You can see why I said when the direction of motion to the right, U will come out first. Okay, alright. So for this one, the P to U. So what is the total displacement? So you just add 0.5 plus 2 plus 4 plus 1.5. Okay, only, oh, sorry, until S only. So until here. So 2.5 plus 4, you got 6.5 meter. Okay, and for this one, yes. For this one, some of you answer to me. Uniform graph, non-uniform graph. Okay, so when he asks you to state the type of motion, there is only non-uniform velocity. Non-uniform velocity is not an answer. Okay, you have to describe. Okay, increasing velocity. Okay, the only thing that I accept, increasing velocity. Okay, decreasing velocity, constant velocity, or zero acceleration, decrease acceleration, or increase acceleration. Okay, there is no words like non-uniform. Okay, you cannot put non-uniform as the type of motion. Okay, cannot use that one to state the type of motion. So from P to S, you can see the distance here increasing. Okay, and V is equals to S over T. So when the S is increased, okay, you can see 0.5 to 2, 2 to 4, right? So it's increasing, the S is increasing here. So that's why for V also increasing. So this one should be the answer, increasing velocity. Or you can say here, acceleration. It will accelerate. Okay, for this one, starting from S to U, you can see the distance is same, right? So when the distance is same here, means the S is not changed. Okay, so when the S is not changing, the V also will not change. So it means if it not change, it will be in uniform velocity. Or you can say zero acceleration. Okay, so this is the answer that I accept. Don't put non-uniform motion, non-uniform velocity. You cannot say non-uniform. There is no type of motion non-uniform. The only thing is increasing, decreasing, constant. uniform velocity. Uniform velocity or constant velocity is the same, right? Okay, and for this one, the objective question, so this one is actually most of you got it correct. So this one is actually base because mass. Okay, so Alex rides his bicycle along a circle track. So the total distance for one complete circle is 9 meter. Okay, and then it said the displacement of Ali to reach the same point. Okay, remember when I teach you, let's say if the A, this is point B. Okay, so let's say you travel from A to B. The distance is 5 meter from A to B. Okay, and then you come back to A. Okay, so when you come back to A, the distance should be 0. Okay, so let's say A to B, this is to the right, right? So let's say I say if you move to the right, okay, if you move to the right, the value, the magnitude should be positive 5. Okay, and then when I come back, okay, when I return back, so now it changed the direction. For displacement, the direction is also considered, right? So it should be opposite, negative 5. So it will become 0. This is for displacement. You have to consider the direction. If they say from A to B is positive 5, so positive 5. And then when it return back, okay, it return back, since displacement, you have to consider the, teacher, can we mark in the paper? Yeah, sure. Oh, sorry. Teacher can go slower a bit, sure. Okay. Starting from this one, right? Number 2? Oh, alright, okay. So, okay, I give you another example. Okay, so let's say this is you. Okay, and this is point A, this is point B. The distance is 5 meter. Okay, so they say you want to travel. Okay, you travel from A to B. Okay, so now you are moving in the right direction, right? So it should be positive 5. Right? Okay, so your displacement. Okay, they say the question asks you to calculate the displacement. Okay, now I'm talking about displacement. Okay, so now you already have positive 5. Okay, so when you return back to A, right, displacement, you have to consider the direction. So now it changed the direction to the left, right? So when it changed to the left, now you have to make the negative 5. Okay, make it negative 5 because it shows that there is a change in direction. Okay, so you should be negative 5 here. So what you will get? 0. Okay, can you get that one? For that one, can you understand why I get 0 for displacement? Okay, so let's say for distance. Yes, distance is a different thing. Because distance, they didn't consider the direction, only the magnitude. So when you travel from A to B, 5 meter, and then you go back to A, so mean the total distance that you travel is 5 plus 5. So you will get 10 meter. Okay, so you can get 10 meter. So that's the difference between the distance and displacement. Okay, and they give you the clue already there. To reach the same point when the ride began. So means that one, it come back to the initial position. Okay, so when you come back to the initial position, the displacement is 0. Right, the displacement is 0. Okay, but let's say they ask you to calculate the distance, then you have to calculate, just ignore the direction. Okay, just add, let's say for this one, it said on the circle track, the total distance, so this one it should be 9, right? 9 meter. Okay, so the answer should be 9 meter if they ask you to find the distance. Okay, let's move on to the number 3. So for number 3, I noticed most of you got it wrong. Okay, some of you put 2.13 if I'm not mistaken, right? Okay, for this one, you can see the ring is not starting from 0, right? If you measure something, of course, you will put the object at the 0 cm, right? The starting point must be in 0. But for this one, it starts from here, okay, at the middle of the vernier calipers. So how you want to calculate the diameter? Okay, so the first thing what you have to do, okay, for this one you already know the main scale is actually equals to 0.1, right? For each of this 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, correct? Okay, so you calculate at the main scale first. Okay, this one is 0.1 for each small scale. Okay, so 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. So now for your main scale is 0.6. Okay, and then after that you read at the vernier scale. So how to read the vernier scale for the vernier calipers? You have to find one line that is straight line. Okay, it forms straight line with the main scale. So if you can see, it's here, right? You see, it form a straight line. For this one, no. This one is not. This one also no. This one also no. So this is the one straight line that form the straight line from the scale vernier to the main scale here. So you read at the below part at the scale vernier. Okay, at the vernier scale. So 1, 2, 3. So plus 0.03. So you will get 0.63. Okay, not 2.13. Okay, I know some of you read here 2 point, so 0 is here, right? So this one is 2.1, and then here to here is same is 3, right? So 2.13. But that one, if they put the ring, okay, on the 0. Okay, but this one is on the middle, so you need to calculate at the main scale first. Okay, you calculate 1. This one don't calculate, start from this one. Okay, this one is like only half, right? So 1, 2, 3, 4, 5, 6. So 0.6. Okay, and then at the below scale, at the vernier scale, you read at below at the vernier scale, you find one straight line here. Okay, so 1, 2, 3. Okay, so plus 0.03. So you will get 0.63. Okay, are you clear? If anything, you can just type in the chat, or you can open your mic. Okay, for number 4. Okay, so table 1 shows the result of an experiment to investigate the relationship between the mass and the acceleration. Okay, so the force is pull by force 20 Newton. Okay, so what is the responding variable? Okay, so for this one, what you can see here, the mass is the relationship that you want to investigate is the mass and the acceleration. So it's only these two. Okay, between these two, one must be manipulated variable and the other one should be responding variable. Okay, so they ask you to find responding variable. So mass is the manipulated variable, while the acceleration should be responding variable. So what is the force? Force is actually the constant variable. So means you pull the same force, okay? When you do the experiment, let's say for the mass 1 kg, okay, you pull with 20 Newton. 2 kg also you pull with 20 Newton. So the force will not change, okay? Will not change in the experiment, okay? So you just see the clue here. What it is investigate? It investigate between the mass and the acceleration. Okay, for the mass, and another clue is in the experiment for the acceleration. Can you change the acceleration? Is there any object that you can use to represent the acceleration? No, right? For the mass, yes, you can use the block or we can use the pendulum. Okay, that one is the mass is already constant there. Okay, but for the acceleration, that one you need to use the formula to calculate. Okay, there is no object, okay, or no measuring tool that can directly find the acceleration. You need to use the formula to find the acceleration. Okay, so that's why it cannot be the acceleration. Some of you said the force is the responding variable. So you have to know the difference. So the acceleration is the one that you need to know. It's the one that you want to find at the end of the acceleration. Sorry, at the end of the experiment. Okay, so I review about this one because I noticed some of you put pause here. Okay, so the answer should be acceleration. So just take the sentence from here. Okay, the answer is in the sentence. Okay, for number 5. So this one, most of you got it correct. So this one is like a ticker tape, right? Okay, one tick is 0.02. That one is for ticker tape. Okay, this one is stroboscope. So they already said the one tick is 0.05. Okay, so one tick is actually this one. In the middle here, you come from the middle here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so one tick is 0.05. You have a 9 tick. Okay, so 0.05 times 9, you got 0.45. Okay, it's different, like it's the same, right? Same like a ticker tape, right? If you have a ticker tape, so but this one tick is 0.02, right? Okay, so for this one, they say you have 1, 2, 3, 4. So 4 times 0.02. Okay, for this one, they use a stroboscope. Okay, so for number 6, okay, Lily accelerates her bicycle at 3 meter second power of -2. So you put A is 3, okay, acceleration from initial velocity of 4. So U is 4, right? And then how long? For 60 seconds. So T is 16. And they ask you to calculate the distance, okay? So this one is actually by using the equation of motion. Remember the one that S is equal U plus V times T, V square, U square plus 2AS, right? Okay, and then another one they got V is U plus AT, okay? And then another one UT square plus half AT square. Okay, so for this question, which one you want to use? Okay, I give you number 1, number 2, number 3, or number 4. Number 2. Okay, so very good. So S, okay, so S you need to find. Sometimes they use distance, sometimes use displacement, sometimes they ask you to calculate how long. So it's actually same. That one is S. Okay, so don't be confused. They say they put distance, displacement, how far is travel. Okay, that one is almost all is that is S. Okay, so S is UT, T is 16 plus half, A is 3, T is 16 square. So I got 448. Okay, 448. Some of you got 196. I don't know how they got 196. Okay, so this one is actually 448 meter. So the answer should be D donkey. Okay, and for number 7, this one is actually the momentum, right? Okay, I can see the notes, okay, that I give. Okay, they got one question like this. They ask you, let's say you displace the ball P, and then what will happen to the rest of the ball? So the Q will stay, R also will stay, S also will stay, only the T will be displaced. Okay, with the same magnitude with P. Okay, so this one is actually the application of the conservation of momentum. Okay, the energy will be transferred, the momentum will be transferred to the ball. So let's say when P hit the Q, Q will transfer the momentum to R will transfer to S will be go to T, then the T will be displaced. Okay, so which following is correct? So the answer is only ball T move to the right with the velocity V. Okay. So that is the answer for number 7. Alright, for number 8, okay, this one is actually the question repeat. Okay, sorry, I didn't notice that one. So anything you want to ask about the question in chapter 2 before I move to the thermal equilibrium? Okay, if anything, just tell me. Okay, for exercise 4.1, okay, thermal equilibrium. So diagram 18 shows a boy who is having a high fever. So his mother patches a cold pack on his forehead. So which of the following statement is correct when the boil and the cold pack are in thermal equilibrium? So remember I said to you, if then you see the word thermal equilibrium, there is three sentences that you need to remember. The first one, the temperature of the object, two object must be same. Okay. And the second one, the rate of heat transfer between two object is same. Okay. And the third one, okay, the net rate of heat transfer between two objects is zero. Okay. So the answer you can see here, the quantity no. Alright, the net rate of heat flows between the boil and the cold pack is zero. So number 18, the answer is B, boil. Okay. And for number 17, which statement is correct? So I already told you, if in the thermal equilibrium, the temperature of both must be equal. Okay, so the answer is A. Okay, for number 17, which of the following statement is correct if there are no heat losses to the surrounding? Okay, so if there is no heat losses to the surrounding, heat absorbed is equals to the heat gain. Heat absorbed is equals to heat loss, right? So this one, heat loss by water is equals to heat gained by water. So this one, the answer should be C, right? Because there is no heat loss. So means you see the same amount, like the one that we did the specific heat capacity, right? The PT is equals to MC theta. We assume the electrical energy that we receive is actually the same as the heat energy that we need to boil the water. Okay, so that one, number 17 is C. Okay, so let's move on to the next question. Okay, so thermal equilibrium is reached when both of them have the same temperature. Right, this one is easy. Okay, so for this one, number 21. Okay, I noticed some of you answered D, right? Actually, for number 21, there is no answer for it. Okay, there is no answer for it. The answer should be this one is actually zero, not equal, right? So the answer is no answer actually. Okay, but some of you answered D. Not some of you, all of you answered D. Okay, but remember this one is wrong because the net rate of heat transfer is not equal, is zero. Okay, so for number 21, no answer. So that's why I didn't take for number 21. Okay. For number 19, I noticed some of you still don't know how to calculate the temperature. Okay, so I give you the formula. This is the formula: L theta minus L0, L100 minus L0 times 100. Okay, L theta is the length of the mercury, right? With the temperature that you need to find. So here the length of mercury, okay, they ask you to find the mercury of theta, right? So here starting from here, right? So 2 plus 17, that is 19. Okay, 19. Okay, minus L0, L0 is 2 cm. Okay, and then L100 is until here. So 2 plus 17 plus 9. So you will get 28, right? So 28 minus 2. So you time 100. So what's the answer that you will got? 17 times 100 divided by 26. So you will get 65.4. Okay, so that is for C. Okay, can you understand now how you want to calculate for the L theta? Any questions? Because some of you got this one wrong. They got like 50, like 65 something. Okay, so L theta starting from here to here. L0 starting from here to here. L100 starting from here to here. So this one you have to add all the value here. Okay, and then times 100. And some of you forgot to times 100. Okay, so be careful. So this one is 65.4. Okay, for number 20, diagram 80 shows two copper blocks touching each other. So which statement is correct when X and Y are at thermal equilibrium? So thermal equilibrium, you need to find the net rate of heat flows between X and Y is 0. So the answer is D. Okay, paper 2. This one, some of you got it wrong. especially for comparison questions. This one, right? Okay, never mind, we will discuss. Okay, for 1A, what does it mean by thermal equilibrium? So I told you already, you can answer by using the three sentence. The first one, the temperature is same, okay, the temperature of block P, okay, is same with the water, okay, or you can say the rate of heat transfer is equal, or you can say net rate of heat transfer between two objects is 0. Okay, you can use all that three sentence, okay, either one, okay, to answer for this question. For number B, for B, right, what is the temperature of block P when it's in thermal equilibrium? So for this one, you just read. So this one should be like 45. Okay, because it start when it reached to 45, it started to become constant here. Okay, so the answer should be 45 degrees Celsius. Okay, for C, explain how block P achieve thermal equilibrium. So for you to explain this one, you need to tell which it transfer from what object to what object. So for this one, it said it put the metal block of mass 300 gram of initial temperature 100 degrees Celsius into the water at the room temperature. So means the heat it transfer from the metal block, okay, metal block to the room temperature, to the water here. Okay, so from the 100 degrees Celsius of the metal block to the water, to the room, to the water at the room temperature. So you need to state, okay, you need to state which direction does the heat transfer. So here from the heat will transfer, okay, heat will transfer from block P to water, 1 mark. Okay, and then after that, you will say here the net rate of heat transfer is 0 and the temperature, okay, of water and block is same. Okay, so that is for the 2 marks. Okay, you need to tell, okay, you need to state, okay, you need to state the direction of heat transfer. Okay, usually for the hot to cold, right? So the hot one is the block, okay, and the cold one is the water. So you have to say that the heat is transferred from the block to the water. Okay, and then you have to say the net rate of heat transfer between the water and the block is 0. Okay, and the temperature of the block and the water is same. So that's how it achieves thermal equilibrium. Okay, so that is for 2 marks. Okay, for 1A. So it says here figure 5.1, diagram 5.1 shows 2 cups of water that are left on the table in the school canteen. Okay, so the first one, 80 degrees, it will go to 28, it will decrease. The 5 degrees Celsius will increase to 28. Okay, the next question asks, okay, tick right the correct answer in the box provided to complete the sentence below. So when the temperature increase, okay, what will happen to the kinetic energy? It will increase. Okay, it will move faster. If you give the heat energy to the molecule, it will move faster. So when it move faster means the speed is increased. And for the kinetic energy, half mv square. So when the speed is increased, the kinetic energy also increase. Okay, for B1, they ask you to compare the initial temperature. So for this one, most of you got it correct. X is higher than Y. Okay, starting from this one. Yeah, I know when it said compare, right? You should put like the higher, the lower, right? Okay, but for this one, the question is different because they use the different diagram, right? They use the different, this one is the temperature decreasing, this one is temperature increasing. So you cannot compare which one is higher, which one is lower. Okay, unless they put two liquid here. Okay, so that one they put two liquid. This one is different because they use the same. Okay, the same material. So, but this one is different. One you need to cool it down. This one it will be heat up. Okay, so you cannot compare like that. So for this one, what you can do is, it said compare how the temperature of the water in cup X and cup Y change with time. So you can say from X, okay, describe one by one. Okay, for X, the temperature is decreasing. Okay, so for cup X, temperature is decreasing. Okay, temperature is decreasing. Okay, for cup Y, okay, temperature is increasing. Okay, and then compare the transfer of heat energy between the surrounding and the water in a cup X. So for the heat energy, the transfer of heat, you compare whether it's absorbed or released. Okay, for the diagram for the cup X, okay, for the cup X, the energy is released. Okay, energy release. Okay, heat energy release. Okay, for cup Y, heat energy is absorbed like that. Okay, and then the next one, relate the change in temperature of water to the transfer of heat energy that occurs. So here you relate. They say if the cup X, the energy is released, right? The energy is released. So what will happen to the temperature? Temperature is decreased. Okay, so that is the relationship. So when the heat energy released, the temperature is decreased. For this one, you only need to put one only, whether you describe for cup X or for cup Y. Okay, so let's say if I put the cup X, okay, so when the heat energy released, the temperature is decreased. Okay, when the heat energy release, okay, the temperature is decreased. Okay, and for C, most of you got this correct. It said cup X and Y become 28. So what is the physics concept here? This is a thermal equilibrium. Okay, so it will not change. Okay, are you clear about this one? For these three exercise that we discussed just now? Any question you want to ask teacher? Okay, I know some of you, if they don't understand, they will just keep quiet. Then after that, when they answer the exercise, okay, all marks, okay, it's gone. Okay, please answer, please ask teacher. Okay, if you are very shy to answer in the chat room, okay, you can text me, okay, privately. Alright, and also if they say you want to Google Meet, they say, teacher, I don't understand the question. Okay, you take the picture and then they say, if I free that one, we can go Google Meet. Okay, for a while, only for that question, I will explain, because some of the question I cannot explain through chat because it's quite hard. So we can do a Google Meet, okay, a short time. Okay, so please ask. Alright, okay, so thank you class for your attendance today. Okay, very good. Okay, so I see you on Monday, okay, for 4S, right? Okay, thank you. Please complete your homework, all right? If anything, just text me, okay? Okay, have a good weekend, all right? Take care, class. Bye.
Thank you, teacher.
Okay,
Thank you, teacher.
welcome,
Thank you,
welcome.
teacher. Bye, teacher.
Okay, bye-bye.